Let's see more example. Okay, for a random variable x with a binomial distribution b, where n equal to 10 and your p equal to 0.4, find a where probability x less than or equal to a equal to 0.633, and b where p probability x greater than a equal to 0.055, and c where probability x equal to a equal to 0.201. So the difference of this equation with the previous question is that here we don't have the value of our r. It's only mentioned as a over here. We don't know the value yet. So the thing here you need to find is the a, no longer the value on this side. See, the value on these sides are given. This is the value you get from the table. But now the value is already given. So what you need to find is the r. Okay, let's see. For a, you need to find the probability x less than or equal to a, which is equal to 0.633. Okay, so if you refer to here 0.633 and you are given your n equal to 10 and your p 0.4. Now let's refer to our table. N equal to 10, it's this side, this area. And your p equal to 0.4. 0.4, it's here, 0.4. So this column. Now you need to find which r that give you this value 0.633. So now you need to refer here. Here this is the 0.633, and this is when you r equal to 4. When you r equal to 4. So you can say that a, the previous a, is actually equal to 4. This is from the probability from the binomial probability table. Okay, so that's the difference between the from the previous question. Let's see question B. Find where p probability x greater than a equal to 0.055. So you need to find the a. But first, you see the sign here is greater than, but our table is only for less than. So you need to rewrite your probability here. So this is actually equal x greater than a, actually equal to 1 minus probability x less than or equal to a, which is equal to 0.055. So now you need to rearrange the position of these probabilities and the values. So you take this value over here, you can bring it on this side, and then this probability you can bring it over on this side. So you have, after you rearrange, you get this structure. So now probability x less than or equal to a equal to this 1 minus 0.055. So you get 0.945. So then you can check to your table 0.945, and then again we refer that n equal to 10 this side, p equal to 0.4 this side, if I'm not mistaken. Sorry, let's check back on this column. Sorry, 0.4. So you need to find 0.945 from the table. 0.945, it's here, it's over here. So if we check back, it is actually r equal to 6. This one, r equal to 6. So we can say that your a, or the r, is actually equal to 6. Okay, the last question, where p, or where probability x equal to a, given this. So now x equal to a. So we have to rewrite this x equal to a. It's actually in this form. probability x less than or equal to a minus probability x less than a. So how do I know it's 5 over here? Why is it 5? Why isn't it 3, 2, or 1, or so on? Because if we refer back to the previous one, here you have a equal to 4 and here you have a equal to 6. So it should be somewhere in the middle. Something in the middle. So it can be 5. Let's trial and error. Okay, let's say this is 5. So a equal to 5. This one also equal to 5. But again, this one probably x equal to 5 less than or equal to 5, and then x less than 5 means x less than or equal to 4. So given by this. If you check back this one, x less than or equal to 5 is actually this one, 0.834 minus this one. For 4, this one. So if you minus these two, you will get 0.201. So it's actually correct. Your a equal to 5. I hope you can understand how to obtain the a or the r value from the table, or the previous question which you need to find the values on this side. So both are equally the same. You need to refer back to your binomial probability table with the less than sign. Okay, let's move on to the next subtopics. The mean and variance of a binomial distribution. Previously, you have learned what is mean, what is variance. Mean also can be written as EX or expectation of X. So the probability distribution for the discrete random variable X is given by this. When X equal to 0, 1, 2, and 3. So the probability is given by this. And x multiply with probability of x, so you get this. X squared multiply with probability of x, you get this. Okay, so the mean is actually equal to EX or expectation of x equal to summation of x times probability of x over here. So that's why we calculated earlier over here, this row. So you can easily find your EX or your mean. So now you have 0 times with this, you get 0, and then you have 25 over 72 times with this, and then times with 1, and then this one times with this one times with this. Okay, so you get all together is 1 over 2. Okay, not over there. The distribution can be described as x followed by binomial where n equal to 3 and the probability of success or p equal to 1 over 6. Okay, this result is what we might expect as n times p, which is your trial times the probability of success. 3 times 1 over 6, you get 1 over 2. So this is actually equal to the expectation or the mean just now. So this is how you're going to obtain your mean. It's actually the same with the random variables we have learned before. This is the formula. How about the variance? Okay, the variance also the same. Expectation of x squared equal to summation of x squared times probability of x. So previously we have this. That's why we have calculated it earlier. This one, x px, and this one for this row you're going to use it for the variance. So all you have is here. I believe that you know how to find this, right? This is just x square x square, the value of x, you square it and then you multiply with the px. So you get this. This one you square, you multiply with this, then you get this. Then you total up all together, then you get this part. So for variance of x, you will have expectation of x square minus expectation square of x. So you have this part. In general, it can be shown that if x follow binomial with n and p, then expectation of x is actually equal to np, and variance of x actually equal to npq, where q equal to 1 minus p. So it can be both ways. You can obtain your expectation, your your mean and variance using both way. Either you want to use it this way or the summation like this, or you want to use this formula and this formula. Both also correct. So I believe this is you're going to use this one because this is the easiest one. You just need to memorize the mean or expectation equal to NP and the variance equal to NPQ. That is for binomial distribution. I can note that NP equal to 3 times 1 over 6 equal to half. This is the mean just now. And for the variance, which is equal to NPQ, N 3, P is 1 over 6, and Q 5 over 6. How do you obtain Q? Q is actually 1 minus your P. So you get 5 over 6. Then you get 5 over 12. So this is actually 5 over 12 over here is actually the same with this one. So that's why I said just now both ways are correct. Either you want to use this formula or you want to use this formula. Both also correct. So note that EX is expectation of X, V capital of VX is variance X minus variance of X. Examples, let's see. An unbiased dice is drawn 300 times. Find the mean and standard deviation of the number 6 is obtained. So dadu tu kita lambung 300 kali. So you need to find the mean and standard deviation of obtaining 6. Okay. So at first you need to let x represent the number of times number 6 is obtained. So that is your event or your random variable. So x follow the binomial distribution with n equal to 300 and the probability of getting 6 is 1 over 6. Why 1 over 6? Because dice have 6 surface. Ada 6 permukaan untuk dadu biasa. So you will get 1/6. So mean or the EX equal to NP. So you just multiply your N and P. So you get 50. And then variance equal to NPQ. So you have N, P, and your Q will be 1 minus P just now. So you get 5 over 6. So you just multiply all of this, you get 41.67. So we know that the standard deviation is actually the square root of variance x. So you just take this and square root, and you get the standard deviation. So that's how you find the standard deviation. More examples. A study of all sets revealed that 2 out of 5 families have a video recorder. A sample of 4 families is randomly selected from the set. Find the probability that 2 or more families having a video recorder. Okay, then B, if there are 900 families in the stats, calculate the mean and standard deviation of the numbers of families who have a video recorder. So at first, you need to let X as your random variable, X represent the number of families have video recorder. So X follow the binomial distribution with n equal to 4. Why is it 4? Because a sample of 4 families is stated here. So 4 families is your n, and then 0 0.4 is the probability of success. Why is it 0 0.4 over here? Because it's that a study of all stat revealed that 2 out of 5. 2 out of 5 means 2 over 5. So you will get 0 0.5 at 0 0.4. 0 0.4 over here. 2 out of 5. 2 over 5. Then you get 0 0.4. So you will have this general equation, which is NCR P to the power of R Q to the power of N minus R. So A, we refer back to question A, a sample of 4 families is randomly selected from the stat. Find the probability that 2 or more families having a video recorder. So you have your N equal to 4 and your R is greater than or equal to 2 or more. Mean that greater than or equal to 2. So you have, if you have greater than or equal to 2, it means that you have x equal to 2, x equal to 3, and x equal to 4. So you have to substitute all the value of your R into this function over here, or small letter of x over here is actually equal to your R. Then you get this answer. Okay, so I repeat, this is for when x equal to 2, this is when x equal to 3, and this is when x equal to 4, up until 4 because there are only 4 families, the maximum. So you get this value. Okay, how about question B? If there are 900 families in the stat, so now you have n equal to 900. Calculate the mean and standard deviation of the numbers of family who have a video recorder. So you need to find the mean or mu or your EX equal to NP. So you know your N, the new N is 900 times P equal to 0 0.4, which is 360. So you obtain your mean, and then your standard deviation. Standard deviation is actually equal to NPQ, and then you square root it. This is like NPQ is actually your variance, and then you square root it. Then you get the standard deviation over here. Okay. Okay, determine the most probable value of x when x follow binomial NP. The most probable value of x is the highest probability of x. So you can say that the most probable value is actually the highest probability of x. Let's see the example. X is a random variable such that x follow binomial 5 at 0 0.3. 5 is your n and 0 0.3 is your p. Find the most probable value of x. The most probable value means x is the highest probability. So first we need to find the mean, ex. So the mean is np. N equal to 5 times your p 0 0.3, so you get 1.5 over here. So now you have, let's try probability x equal to 0. So when x equal to 0, you have 5 CR and CR. You just follow the formula previously, and CR PR times QN minus R. So you just substitute the value of R over here. So you get this one. And then we try for when x equal to 1. Then you get this answer. Then you try for x equal to 2. So you get this answer. Thus, you can see that which one is the highest? Is it this one, or this one? It's actually this one, right? when x equal to 1. Therefore, x equal to 1 is the most probable value of x because its probability is the highest. Among these three, this is the highest. So we can say that x equal to 1 is the most probable value of x. Example 2. X is a random variable such that x follow binomial distribution where n equal to 8 and p equal to 0.25. Find the most probable value of x. Again, you need to find the most probable value, which is the highest probability. So first you need to find your ex, which is equal to np. Multiply these two, n and p, you get 2. So we try x equal, let's start with x equal to 0. So substitute the value and then you get this. Try again with x equal to 1. Then you get the value x equal to 2, x equal to 3, and so on. And then you refer to this. Which one is the highest? This one, right? So it's actually when x equal to 2 because its probability is the highest. More examples. In a biology examination, 45% of the students pass. If a class of 20 students take the examination, find the probability that exactly 15 students pass. B, at least 2 students pass, and C, more than 16 students pass. So the solution, this situation can be modeled by a binomial distribution because the number of trial is fixed. In this case, each student represents a trial. And then there are only two outcomes. Success means student passed the examination. And failure means the student failed the exam. And the third one, each trial is independent, which means that the probability of success is the same for each trial. We can assume it is the same for each student as each student is chosen at random and each student's performance is no way affects the performance of others. So maksudnya dekat sini dia tidak kebarangkalian yang kamu dapat tu dia tidak bergantung dengan kebarangkalian yang sebelumnya. So that is apa yang dimaksudkan dengan independent. So first we need to let x be the number of students who pass the examination, where x follow the binomial distribution with n equal to 20 because 20 students. So n equal to 20 and 45% student pass means 0.45. The p is 0.45. Then you need to find a probability of exactly 15 student pass. So this will be your r, or your small letter of x. Probability of x equal to 15. So you just need to use NCR p to the power of RQ n minus r. Your n is 20, then your r is 15, your p is 0.45 to the power of r, and this q. How do you find q? 1 minus 0.45. So you get this one, q. So you get the answer. And b, you need to find at least 2 students pass. At least 2 students, which means that probability of x greater than or equal to 2. Okay, remember we don't have a greater than sign in our table, so you should rewrite it in less than sign form. So you have 1 minus probability x less than or equal to 1. So this is actually equal to 1 minus less than or equal to 1 means probability x equal to 0 and probability x equal to 1. So this one you can substitute the value into the formula of NCRPRQ to the power of n minus r. So this is for when x equal to 0 and this is for when x equal to 1. So at last you will have this value. And For C, you need to find the probability of getting more than 16 student pass. So more than 16 means probability X greater than 16, which is 17, 18, 19, and 20. Enough until 20 because you only have 20 students. Okay, then again you have to substitute the value of this into the formula. This is when x equal to 17, this is when x equal to 18, x equal to 19, and x equal to 20. So you're going to sum up all of these values over here, then you get this is the answer. Then next example. A box contains a very large number of red and yellow tulip bulbs in the ratio 1 to 3. Bulbs are, bulbs are picked at random from the box. How many bulbs must be picked so that the probability that there is at least one red tulip bulb among them is greater than 0.95? So apa yang dikata dekat sini, dalam satu kotak kita ada very large number of red. Kita ada banyak bulb berwarna merah dan kuning dengan nisbah 1 kepada 3. Yang mana red bulb ada nisbah dia dalam kuantiti 1 and then the yellow bulb dalam nisbah 3, 1 kepada 3. Bulbs are picked at random from the box. Bulb tu kita ambil secara random. How many bulb must be picked so that the probability that there is at least one red tulip bulb among them is greater than 0.95. So dekat sini you need to cari berapa bilangan bulb yang mesti diambil so that the probability untuk dapat at least satu red bulb adalah greater than 0.95. So soalan dia agak panjang. So solution, this can be modeled by a binomial distribution juga. Kenapa? Sebab the first one, the number of trials is fixed. The number of trials is fixed. This is in fact when what we are trying to find. But once we have found the number of trial, it will be fixed. See, we don't have our n yet over here. We don't know how many n. Okay, but we sure it is fixed. And then we can take success to be picking a red tulip bulb and failure to be picking a yellow tulip bulb. So we have two outcomes. The first one, when you pick the red bulb, and the second outcome is when you're picking a yellow bulb. So picking a red bulb is your success. Okay, and each trial is independent. Independent means although we are not replacing the bulb after they have been selected, the number of bulb is very large. We can therefore assume the probability remains the same. So let's solve the problem. We know that the red and yellow bulbs are in the ratio 1 to 3. So our probability of success is 1 over 4. 1 over 4, 4 over here is 1 plus 3. This is the ratio, so the total will be 4. And probability of success is the probability of getting red bulb. So red bulb, we know this is 1 is for red and 3 is for yellow. So 1 over 4. This is why we get 1 over 4 over here. So if x is the number of red tulip bulbs, we can say that x is the red tulips. X follow the binomial distribution with n is unknown. We still don't know the n, but p, we already found out the p, which is equal to 1 over 4. So we want to find n such that probability x greater than or equal to 1, greater than 0.95. So we need to find our n over here so that this probability mesti greater daripada 0.95. 5. So we have probability x greater than or equal to 1. Again, remember we don't have greater than sign in our table. All we have is only less than. So what you need to do, you need to rewrite it. So in the less than sign, this is actually 1 minus probability x less than or equal to 0. So this is actually this probability x equal to 0. So how do you find probability x equal to 0? You just substitute the value of n in, and we still remain to use n. And CR, your r equal to 0. P is this to the power of r. Q is 3 over 4, 1 minus this, and n remain this. So that's why you get this part. We still don't know the n. So now you have 1 minus 0.7 to the power of n must be greater than 0.95. So all you need to do is we rearrange this position. 0.95 we bring it this side, and then 0.75 we bring over to the right hand side. So 1 minus 0.95 you get 0.05. And then we will take the ln over here. Why? Because we have power of n over here. So we take ln for both sides. Sorry, not ln, log. You take log for both sides. So you will have log 0.05 greater than log 0.75 to the power of n. And remember, when you have to the power of n over here, you can bring it to the front. So you will have this. And then you can find this. You can simply calculate it using calculator. So you'll get this value. And how about this? You still cannot figure out the value, but you still can calculate using the calculator. Just key in log 0.75. You will get this value, negative 0.125 times with n. So n must be greater than this thing over here. Sorry. Okay, then we rearrange this. So this thing over here, you're going to bring it over here. So you will have negative 1.301 divided by negative 0.125. So you get your n must be greater than 10.4. Remember, we cannot have n in point form or decimal form. So you need to round up your value of n. So the least value of n is 11. So 10.4, the closest one is 11, round up. In other words, at least 11 bulbs must be picked out of the bag. So that's the answer, at least n equal to 11. Don't worry, for this question you don't need to refer to the table. All you need is to refresh all the information you are been given to you. Just make use all of it. So this is the answer. I guess this is the last examples. Yes, this is the last examples. If the probability that it will be a fine day is 0.4, find the expected number of fine days in a week and the standard deviation. Okay, now let a fine day be a success. Therefore, probability of success equal to 0.4. So this situation also can be modeled by binomial. Your n will be 7 because it's mentioned that in a week. In a week mean we have 7 days, 7 hari. So your n equal to 7. There are only 2 outcomes, which is success is fine day. So 2 outcomes, success is fine day and failure will be rainy day, hari yang hujan. Fine day means hari yang cerah. And the probability of success is the same. Okay, probability of success is the same, which is 0.4. So we have our random variable written in this form. X for the binomial with n equal to 7, you 7 days, and the probability of getting 5 days is 0.5, 0.4. Okay, to find the expected numbers of 5 days, we must find the mean. So mean equal to np. So you just multiply your n and p, you'll get 2.8 days. And then your variance, you need to find your variance, npq, npq, and 7p 0.4 and q 0.6. That is your variance. So your standard deviation is, you will take the square root of 1.68, you get 1.30 days. So that's it. You need to find the expected numbers, which is the mean, and then you need to find the standard deviation, which is this. So that's all the examples. Uh, you might want to try the exercise with the given answers. That's all about the part 1, which is the binomial distribution. Thank you for watching.